Hello learners, welcome to today's lesson. This is Form 4 Mathematics under Longitudes and Latitudes. But before we look at longitudes and latitudes, let us look at the shape of the earth. We know that the shape of the earth is spherical, and there are so many physical features which are found on the earth's surface, which include mountains, we have rivers, we have oceans, and even buildings. To locate the position of all these physical features on the earth's surface, we use longitudes and latitudes. So longitudes are imaginary lines drawn on the earth's surface, and they run from north to south. Equally, when we talk about latitudes, there are also imaginary lines which are drawn on the earth's surface, and they run from west to east. So when we talk about longitudes, we have the main longitude which goes through the center of the earth, and since it is the main longitude, we call it the prime meridian. It can also be called the Greenwich meridian, since it passes through the center of the earth and also through a very small village in London known as the Greenwich. So we can call it either the prime meridian or the Greenwich meridian. These longitudes are used to locate the positions of these physical features on the earth's surface. Another thing is that we have latitudes, but we have the main latitude which we call the equator, from where all other latitudes are going to be located or measured. Usually, since the Greenwich or the prime meridian is the main meridian or longitude, we always give it a degree reference of 0 degrees. From there we have longitudes to the east. We also have those longitudes to the west. So this is our west, this is our east. From 0 degrees, we can say, assuming we measure the degree position of this longitude, and for example you find it to be around 50 degrees, and then you measure the position of this one here and you find it to be around 80 degrees, since they are to the east of the prime meridian, we say this longitude is 50 degrees east and this one is 80 degrees east of the prime meridian. We can also measure from 0 to this longitude, and assuming this longitude is around 60 degrees, and since it is to the west, we say this longitude is 60 degrees west. We can also measure the size of this one, and for example from 0 to this longitude we have 70 degrees, and since it is to the west, we can say it is 70 degrees west. Another thing we are going to talk about are the latitudes. The latitudes are measured in reference to the equator, since it is the latitude that goes through the center of the earth. Since it is the main latitude, it is also given a degree reference of 0. From there, all other latitudes are given positions. Assuming you measure from 0 to this point and say we have, for example, 30 degrees, since it is to the southern part of the equator, we say this one is 30 degrees south. We can also measure the size or the degree difference from 0 to this latitude, and let's say it's around 75 degrees. Since it is to the south, we say it is 75 degrees south. We can also measure those which are above the equator. Say you have measured this one and it is 40 degrees. Since it is to the northern part, we say it is 40 degrees north. We can also measure this and maybe we say it is 60 degrees north. From there now, These longitudes and latitudes are used to locate the positions of places or points on the Earth's surface. Assuming we give this point here point A, then we have another point here, for example, point B. We also have another point, say this is a point C. We also have another point here like point Q. We can as well pick this point and give it, for example, M, and also pick this point and give it point N. And you are told, for example, to locate the position of point A on the Earth's surface. When we are locating the position of a point, we first start by identifying the latitude, and lastly, we identify the longitude where that particular point lies. So, point A lies 80 degrees north of the equator, that is 80 degrees north. Then the longitude of A is 70 degrees, but to the west. If you want to locate the position of a point, for example, C, C lies on what latitude? C lies 40 degrees above the equator. Then let us look at the longitude. This is C and it lies on the longitude 50. It is 50 degrees, but since it is 50 degrees east of the prime meridian, we say it is 50 degrees east. Let us, for example, give the position of a point like M. If somebody tells you to give the position of point M, M lies on which latitude first? 75 degrees south. Then we identify the longitude for M, and the longitude is 80 degrees but east. Let me try to locate, for example, a point like Q. If you are, for example, told to identify the position of Q, first we look at the latitude. Q is 80 degrees north, but 50 degrees east. So it is very, very simple for one to identify the position of a point by using longitudes and latitudes. Apart from identifying the position of a point on the Earth's surface, the student is also required to know how to calculate the distance between any 2 points on the Earth's surface. When it comes to calculation of distance, we group longitudes and latitudes into circles, where all longitudes, including the equator, we call them great circles, and we call them great circles because they have a radius equal to that of the Earth. Then when it comes to small circles, we say all latitudes are small circles except the equator. That means anytime you want to calculate distance, you need to know if the 2 points are lying on a great circle. How do you know that 2 points lie on a great circle? Great circles are longitudes. So if they share longitudes, you should automatically know that those 2 points lie on a great circle. For example, if you have been asked to calculate the distance, for example, the distance between a point like M, let me use a point like C, and C is 40 degrees north, 50 degrees east. We also have a point, the distance between, let me say, C and a Q, and our Q here is 80 degrees north and 50 degrees east. So when you look at these 2 points, you realize the 2 points share the same longitude. They are found in the same longitude, and therefore they lie on a great circle. They lie on a great circle. Distances between any 2 points on the Earth's surface can either be measured in kilometers or in nautical miles. If you want to find the distance between C and Q in kilometers, then we say distance between any 2 points that lie on a great circle in kilometers are given by theta over 360 times 2 pi r, where our theta represents the latitude difference, and our r represents the radius of the earth, which is approximately 6370 kilometers. So in short, distance between any 2 points on the earth's surface in kilometers which lie on a great circle is given by theta over 360 2 pi r, where theta is our latitude difference. In this case, if you want to find the latitude difference, if the 2 points are 40 degrees north, 80 degrees north, and both of them are north, we subtract the two so that we can find the difference in latitude between those 2 points. Another thing is that you can also be asked to calculate distance in nautical miles. If somebody tells you to calculate distance in nautical miles between any 2 points that lie on a great circle, then distance is given by what we call 60. You multiply by theta, where theta is our latitude difference. Another thing that one can be asked, it is to calculate distance between any 2 points that lie on, for example, a small circle. How do you know that 2 points lie on a small circle? For small circles, where we have said all latitudes are small circles, for example, if somebody gives you a point like A, and A lies 80 degrees north and 70 degrees west, we also have a point Q which lies 80 degrees north and 50 degrees east, and you are supposed to calculate the distance between A and Q. The first thing you need to ask yourself, do these 2 points lie on a great circle or a small circle? If they share the latitude, since all latitudes except the equator are small circles, you should know that the 2 points lie on a small circle. And if you want to calculate the distance AQ between these 2 points that lie on a small circle, then distance is going to be equal to alpha over 360 times 2 pi r, then cos theta, where our alpha represents the longitude difference, but our theta does not represent actually the latitude difference as in great circles, but stands for the latitude position. The latitude position. That is to say, if you want to calculate the distance between AQ, if you want to calculate the distance between AQ here, distance AQ is going to be equal to, that is in kilometers, our alpha, which is going to be equal to the longitude difference, and the 2 points, one is 70 degrees west, another one is 50 degrees east. Since one is to the west, another one is to the east, we always add the 2 for us to get our longitude difference. So if you take 70 plus 50, you get 120. That is our alpha. Divide by 360 times 2 times 22 over 7 times 6370, which is the radius of the earth. We multiply by the cos of the latitude position. The 2 points are raised 80 degrees north, and therefore we say cos 80 degrees, and whatever you get here should be in kilometers. You can also be asked to calculate the distance between A and Q in nautical miles. If somebody tells you to calculate the distance in nautical miles and the 2 points lie on a small circle, then we are going to take our alpha, we multiply by 60, then cos theta, where theta represents the latitude position and our alpha is the longitude difference. Apart from calculating what we call distance between any 2 points on the Earth's surface, you can also be asked something to do with time. So what brings about time when the Earth is rotating is the longitude difference. And we know in one day the Earth rotates through 360 degrees. That means in one day the earth covers 360 degrees. In other words, if in one day, which is 24 hours, it takes 360 degrees, if for example we divide by 24 here, by 24 you realize this one and this one goes, 1 hour will always require how many degrees? In this case, if you divide this, if you divide, or we can simply go straight and say, we can always use this equivalent. In every 1 degree, the earth takes 4 minutes. In this case, if we were supposed to calculate the time difference between A and Q, we ask ourselves, if 1 degree goes for 4 minutes, what about 120 degrees? 120 degrees will be equal to how many minutes? It will be 120 times 4 minutes. Then you divide by 60 to change them into hours. And if you've been given time at point A and you need time at point Q, which is ahead, we always add the time difference so that we can get the time that is ahead. And if you're given the time that is ahead and you are supposed to look for the time that is behind, you simply work out the longitude difference, convert it into minutes, then now you subtract for us to be able to get the time in a zone that is behind another one.